Hi guys, hope you're all doing well. So today we are going to start section 5-5, which is function operations. This is going to be a fairly easy lesson in the beginning, as it is things that you are familiar with, such as adding, subtracting, multiplying, dividing functions. And then later on in the second half of the section, we're going to get into some new material, which is compositions of functions. So to start off, all of the triads are going to be on pages 132 and 133 of your student companion. So we're going to start off with example 1 in your notes packet, section 5-5. So first it says, how do you define the sum of f plus g of the functions f of x equals 3x plus 4 and g of x equals x squared minus 5x plus 2? So what is the sum of these two functions? So they define f as 3x plus 4 and g as x squared minus 5x plus 2. All we have to do is find f plus g. So, in other words, f of x plus g of x. Well, if f of x is 3x plus 4, and I'm going to add g of x, x squared minus 5x plus 2, all I have to do here is combine like terms. So I have x squared, 3x minus 5x minus 2x, 4 plus 2, 6. And we are done. That's f plus g. Easy enough? Alright, so there's one small trick when we're dealing with subtraction, f minus g. When dealing with subtraction, if I were to write this down as 3x minus 4, right? That's f minus g. Well, what did I do wrong there? I'm not actually subtracting all of g. I'm only subtracting the x squared. But g of x is all of this, x squared minus 5x plus 2. I want to subtract all of g of x. So it's extremely important that in subtraction specifically, you use parentheses. Because what are we going to do with that negative sign? What are we going to do with that minus? First step is we are going to make it a plus and distribute. So we're going to distribute that negative sign to every term after. So now I could just combine like terms. So I have negative x squared, 3x plus 5x, 8x, negative 4 minus 2, negative 6. And that is defined as f minus g. So guys, don't forget, when adding, nice and easy, just combine like terms. But when when you're subtracting, make sure you subtract the entire function by using parentheses around that function. Alright, go ahead and pause this video, turn to page 132 of your student companion, and try these two problems. When you're ready, you could unpause the video to see the solutions. Alright, so here we're adding f plus g, so we have 2x squared plus 7x minus 1 plus 3 minus 2x. We go ahead and combine like terms. We get 2x squared plus 5x plus 2. Here we have f minus g, so when I write this down, I'm going to write down the function f. I'm going to subtract, and I'm going to use parentheses. 3 minus 2x. I'm then going to distribute that negative. So I get 2x squared plus 9x minus 4. I'm done. Alright, let's go ahead and take a look at example 2. So we're going to be dealing with a lot of real world applications in this section. Since we are talking about operations with functions. So one operation that we're going to talk about is revenue. So as it shows in the diagram here, revenue is equal to the price of a product multiplied by the demand of that product. So here we have the demand D in units sold for a company's new brand of cell phones at a price X. So the price is X in dollars. Is D of X equals 5,000 minus 10X. So X represents the price of the cell phone, and D of X represents the demand of the cell phone. What is the company's expected revenue from cell phone sales in terms of price X? So here, like we said, revenue is equal to price times demand. So if I want to find the revenue, we have the price. Well, what's the price of each cell phone? In this case, it's X. What's the demand of each cell phone? In this case, it's 5,000 minus 10X. So we want to multiply the price times the demand to get the revenue. So we have X times 5,000 minus 10X. Well, we all know how to multiply functions, right? All we have to do is distribute. So we get 5,000 minus 10x squared. So this represents the company's expected revenue from cell phone sales in terms of the price, which is X. This should say 5,000x. All right. Go ahead and pause this video and try the try it problem. So again, this time it gives us that the demand is this and the price is this. And we understand that revenue is equal to price times demand. So in this case, revenue is equal to negative 0.25x squared plus 1,000 multiplied by the price, which is x plus 16. Guys, if you don't like this decimal, use a calculator. So now we have a binomial multiplied by another binomial, so we know we're going to FOIL. So negative 0.25x squared times x is negative 0.25x cubed. Negative 0.25x squared times 16 is negative 4x squared. The inner, we have 1,000 times x, 1,000x. And lastly, we have 1,000 times 16, which gives us 16,000. Now, we don't have any like terms, so this is our revenue function. Done. So it's price times revenue. All right. Let's take a look at example 3. So here in example 3, it's asking us how do we define the quotient f divided by g given the function f of x is equal to x minus 7 and g of x is equal to 2x squared minus 13x minus 7. So now I'm dividing. I'm pretty sure we all learned how to divide in the last chapter. So we have f divided by g, so that's x minus 7 divided by 2x squared minus 13x minus 7. Well, that just means I cross out my x's, right? No, of course not. Anytime we have terms that are being added and subtracted, we can never cross things out, right? We can only simplify if the terms are being multiplied or divided. Therefore, what do we have to do here? We have to factor anything that is factorable. So x minus 7, well, that's not factorable. But 2x squared minus 13x minus 7, yes, that's a quadratic, that's factorable. So on the side here, I'm going to factor. What multiplies to AC? So negative 14, that adds to B, negative 13. What multiplies to negative 14, that adds to negative 13, negative 14, and 1. Can I just jump to my factors, x minus 14, x plus 1? No. Why? Because we have an a value that is not 1. So I have to use grouping. So on the side here, I'm going to rewrite my middle term, negative 13x. I'm going to take that out and put in negative 14x plus 1x. And I'm going to use grouping to factor. Notice here, what's the greatest common factor? A 2x, leaving me with x minus 7. And notice here, the only thing I could factor out is a 1. So now I could replace this. This is now x minus 7 times 2x plus 1. So now I'm going to replace this denominator with my two factors, x minus 7 times 2x plus 1. Now that I've factored it, now I turned it into two terms being multiplied. Now I am able to simplify, just like we did in the previous chapter. So what do I have left in my numerator? Just a 1. And in my denominator, I have 2x plus 1. Remember, if a is not 1 in your trinomial, you must use grouping. Alright, go ahead and pause this video and try example 3. Try its A and B. So notice for number 1, luckily a is 1, so I'm thinking what multiplies to negative 18 adds to negative 3, and I get negative 6 and positive 3. Notice here, because a is 1, and only because a is 1, I could jump to my two factors. I see they have an x plus 3 in common, so I'm left with x minus 6. So f divided by g is equal to x minus 6 for try it A. Alright, for the second one, we have x minus 3 divided by x squared minus x minus 6. So I need to factor this quadratic, so on the side, what multiplies to negative 6 adds to negative 1, and I get negative 3 and positive 2. Again, because a is 1, I could jump to my factors, x minus 3, x plus 2. I notice they have an x minus 3 in common, so I'm left with 1 over x plus 2. So in part B, f divided by g is defined as 1 over x plus 2. Alright, the last thing I really want to quickly talk about is domain. So remember when we talked about domain in the previous chapter, remember our denominator can never equal 0. It is undefined if the denominator is 0. And we don't look at the final answer, but we look at the original problem. So in the original problem here, what could x not be? Our domain could be all real numbers, but x cannot be negative 3, because that would have made this original denominator 0. So all real numbers, but x cannot be negative 3. Here we see our domain is also all real numbers, but what's our restriction? Again, always look at the original. Here we see our denominator was originally x minus 3, x plus 2. So therefore, what would make this 0, 3, or negative 2? So all real numbers, but x cannot be 3 or negative 2. Okay, so always look at the original denominator. There are restrictions here because we cannot divide by 0. So look at the original and to see, okay, what value would make that denominator 0, because x could be any number but that one. Okay, so a lot of this is a review of things you already know. The next half of the section will be an introduction to some newer topics. Make sure you are practicing this. And again, if you have questions, please reach out. Okay, I hope you have a great day.